Alright, so in this video I'm going to talk about the conic section in ellipse, and we're going to take an equation and graph it. We're also going to take the characteristics of an ellipse and write the equation. So let's take a look at the first one. It says graph the following ellipse, and it gives us this equation for an ellipse right here. So let's go ahead and think about what this equation tells us, and as we do that, sketch a picture of this graph. Alright, so whenever I have an equation for an ellipse, I know that the center is what we call HK, and that comes from this part inside the parentheses with X, and this part, this one right here, inside the parentheses with Y. So the center of this ellipse is going to be 3, because that would make this term 0, comma, and -1, because that's the Y value that would make this term 0. So our center is going to be at 3, -1. So I'm going to go ahead and plot that. 1, 2, 3, -1. That's my center. Okay, now we also learned that within ellipse we have these two values underneath on our denominators, and we call them like our A and our B value. This is A squared and this is B squared. And they basically tell us the distance we're going to go side to side and up and down to our vertices and our co-vertices. Underneath our X term here, this is going to give us the value that we go side to side. So think X is side to side. So if this is 36, the square root of that would be 6. So this is 6 squared. So I'm going to go 6 left and right. So 1, 2, 3, 4, 5, 6. There's one of my vertices. 1, 2, 3, 4, 5, 6. Over here at -3 is going to be my other vertice. Okay, great. Little V's for vertices there. Since this has a 9 underneath it and Y is up and down, that means that we're going to go the square root of 9, which is 3, up and down. So 1, 2, 3, up here at 2, and 1, 2, 3 down here at -4 would be my co-vertices. And we end up with an ellipse that looks something like this. Just to review some vocab, this is what we would call our major axis. It's our longer axis. And this is what we would call our minor axis. So our major axis has a total length of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And our minor axis has a total length of 1, 2, 3, 4, 5, 6. A total length of 6. Something else we might be interested in finding that I'll go ahead and go over right now is your foci. I didn't specifically ask for this, but a lot of times you will be asked about your foci. Your foci are the 2 points that are on the major axis of your ellipse, and the definition of an ellipse is all the points such that the sum of the distances from those 2 foci points remains constant. So a lot of times we're going to be asked about those, like I mentioned. So how do we find them? Well, the distance to the foci is what we're going to call C, and for any ellipse we know that C squared should equal A squared minus B squared. So as long as I have A and B right here, I should be able to find C, the distance to my foci. So let's go ahead and do that. C squared would be 36 minus 9. 36 minus 9 is 27. And when I take the square root of that, I get C would be plus or minus root 27. So I want to go from the center forward root 27 and backwards root 27. Now let's think about how big that would be. That's roughly going to be 5 point something, since 5 squared is 25, which is too small, but 6 squared would be 36. That's too much. So we know it's going to be 5 and a little bit more. So let's go forward 5 and backwards 5. 1, 2, 3, 4, 5, and a little bit. There's going to be one of them. And backwards, 1, 2, 3, 4, 5, and a little bit. Okay, so what are the coordinates of these? If we wanted to write them, well, I know that both of them are along this major axis right here. So the foci have for sure a y coordinate of -1. If you look, they're both down 1. Okay. The x-coordinate's a little bit harder though, because it's somewhere right here between these 2 tick marks, and this one's somewhere between these 2 tick marks. So a little bit harder for us to find. So the best we can do is write it as an expression from the center, the distance that we went. So the center is right here at an x value of 3. And we went from 3 forward root 27 or 5-ish, and we went backwards root 27 or 5-ish. So one of them is going to be plus root 27. That's going to be this one over here on the right side. And then this one would be minus root 27. So I know that's a little bit small, but we end up with 3 plus root 27 comma negative 1 and 3 minus root 27 comma negative 1. Okay, so we got the foci, we've got kind of a review of all of our vocab terms there, and then we did what the question asked, which is to graph it. Okay, next one. Let's take a look. It says find the equation of an ellipse with foci located at -4, 3, and 2, 3, where the major axis has a total length of 10. So anytime I have a conic section problem, as I've mentioned before, I'm going to draw myself a picture and see what I'm looking at, and that should help us to get started. So let's plot the foci. I've got -4, 3, and I've got another one at 2, 3. And I'm going to put a little f next to them to remember later that those are the foci, not the vertices or the covertices. Okay, now my foci are always equidistant from my center. So if this is a total distance of 1, 2, 3, 4, 5, 6, then I know that 1, 2, 3 would be, this would be my center right here. So my center is going to be at -1, 3. So that's a good starting point right there.